We are going to demonstrate how to perform the direct shear test. Dry quartz sand will be used for this demonstration. This is the direct shear box, which can be divided into upper and lower parts. During the test, shear force will be applied to the specimen by pushing horizontally the upper part of the shear box. We will measure the displacement and force in both horizontal and vertical directions. Let's see what will be put inside the shear box. There should be upper and lower power stones, lower and upper grid plates, top cap, and a base plate. To assemble the shear box and the specimen, we first put the base plate inside the shear box, which can then be put inside the shear device. Next, we will place the lower power stone. Power stones can be made of a variety of materials. Today, we have chosen a brass stone because the specimen is completely dry. If the specimen is not dry, then we can use a power stone that is truly permeable. Next, we can place the lower grid plate. The thread of the grid plate should be perpendicular to the direction of the applied shear force, such that friction can be developed during shearing. Above the lower grid plate, we can place our specimen. Today, we use quartz sand that weighs about 105 grams. Use a spoon to level the soil. The property of the sandy soil depends on its degree of compactness. We can use a compaction plate to compact the soil. The fall ratio can be controlled by the mass of the soil used to prepare the specimen. There is a marker on the compaction plate which indicates the height of the specimen for which we should compact. In the experiment, we would vary the normal force in the vertical direction that is applied on the specimen. Make sure that there are no soil particles remaining on the compaction plate. Next, we can place the upper grid plate and the upper power stone. Make sure that the direction of the thread is perpendicular to the direction of the applied shear force. The specimen preparation process is now complete. Now we can set up the dial gauge and the loading frame. We have to adjust the contact for the lever. The lever has to be level. For our device, the lever ratio is 1 to 10, which means that if we place a dead weight of 1 kg at the end of the lever, 10 kg will be applied on the specimen through the loading frame. The contact for the lever can be controlled by the screw at the top of the loading frame. Next, we can set up the dial gauge. Make sure that it is vertical and use an appropriate stroke length. We can then set up the devices for providing the horizontal force and measuring the horizontal displacement. The horizontal force is provided through this proving ring. It acts like a spring. For example, this proving ring has a spring constant of 0.3185 kg per 1 division on the dial gauge. For the horizontal displacement, we would measure through this dial gauge that is placed horizontally. In general, direct shear tests can be conducted by either controlling the shear stress or the shear strain. For the device in this soil laboratory, the direct shear test is shear strain controlled. Indicated here are the speeds at which the horizontal displacement can be applied. This speed is set by adjusting the gear 1, 2, or 3 and the setting number. Today, we want to apply the shear quickly with a horizontal displacement of 1.2 mm per minute. For this device, we would use gear 1 and setting number of 572. To speed up the test, we should minimize the gap between the shear box and the surrounding container. If they are in contact, the proving ring will start to measurement. Before we start the test, we have to remove the 2 steel nails which are used to fix the shear box in place. Next, we use 2 brass nails to help separate the upper and lower parts of the shear box. Our goal is to evaluate the shear strength of the soil. But if the brass nails are in contact with the lower part of the shear box, the measured strength will be contributing from both the soil strength and the friction between the 2 parts of the shear box. We should adjust the brass nails such that the tips of them will be touching the lower parts, with an additional round of screwing. Make sure that both nails are approximately at the same level. After we have ensured that the upper and lower parts of the shear box have been separated, we can unscrew the brass nails. Take a look at the dial gauge for measuring the vertical displacement. In this experiment, it's possible to have expansion or compression. Make sure you know how to differentiate between expansion and compression on this dial gauge. We set the dial gauges for indicating the horizontal measurement and horizontal force. For the direct shear test performed in this lab, all the measurements are recorded manually. However, in the graduate soil lab and consulting firms, the measurements are mostly recorded digitally by computers. Now all the dial gauges have been reset. We can start the shearing. In the beginning, many readings of the proving ring and the vertical dial gauge should be taken. For each 5 divisions of the horizontal dial gauge, there should be 1 reading of the proving ring and the vertical dial gauge. After 100 divisions, 1 reading will be taken per 10 divisions of the horizontal dial gauge. We have to determine when we should stop the test. Ideally, it should be when the soil strength has been reached. However, the stress-strain behavior depends on the denseness of soil. For densely packed soil, the peak strength may be reached and followed by a decrease in shear stress. Hence, the strength can be easily identified. For loose soil, the shear strength may increase and gradually level off. In this case, we will consider the shear strength to be the shear stress at shear strain of 20%. Now the upper shear box is being pushed. We can see the horizontal force and horizontal displacement are increasing. On the other hand, the vertical displacement may be relatively small. For dense sand, you may expect to see compression in the beginning, which will be followed by expansion. The test will continue until you see a drop in the horizontal force.